With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, let's discuss the question. The function f r to r defined as fx equal to x square minus x plus 1 upon x square plus x plus 1 is, and four options are given, that is we have to check the injectivity and surjectivity of this function. So we can write our function, that is y, and this y will be equal to x square minus x plus 1 upon x square plus x plus 1, and its codomain is given as r, and its domain is also given as all real values of x. So we can say that domain, this x belongs to r, and codomain, this is y belongs to r. So first we will find the range of this function, and then we will check the injectivity and surjectivity of this function. So from here we will just multiply this term into this side. So we get this as yx square, and here will be this xy, and here will be this plus 1, and that will be equal to x square, here will be plus y, and this will be x square minus x plus 1. So from here if we will take this term on this side, we get as this y minus 1, and here will be x square. Similarly, if we will take this on this side, here will be this y plus 1 multiplied by x, and here will be this y minus 1, and that will be equal to 0. Since x belongs to r, that is here, so we can say that discriminant of this quadratic equation must be greater than 0. So this y plus 1, that is d greater than 0 or equal to 0. D must be equal to 0 also, because for real values d is greater than or equal to 0. So from here y plus 1 whole square, that is b square minus 4 into ac, so this will be y minus 1, and this is also y minus 1, and that will be greater than or equal to 0. So from here this will be y plus 1 whole square, and this can be written as minus 2y minus 2 whole square. What we have done, this multiplying this 2 and taking as the whole square, so that will be greater than or equal to 0. So here we will use the identity a plus b into a minus b. So two factor will be there, that is y plus 1 plus 2y minus 2, and another factor will be y plus 1 and minus 2y plus 2. So minus 2y plus 2, and that must be greater than or equal to 0. So from here this will be y plus 2y, that is 3y, and this will become minus 1. So 3y minus 1, and here this will be minus y and 3. So this will be 3 minus y, and this will be greater than or equal to 0. So if we will change the sign here, that is 3 minus y, that will be written as y minus 3 by changing the inequality. So that will be 3y minus 1, and this will be y minus 3, and that will be less than or equal to 0. So here we will solve this inequality. So the critical points for this inequality are this y equal to 1 by 3, and this will be y equal to 3. So if we will substitute a value that is greater than this 3, then this bracket will be positive, and similarly this bracket will also be positive. So here we can say that if any value will be greater than this 3, the function must be positive, so this will be plus. And similarly, if we will substitute any value between these two, then this bracket will be positive and this will be negative, so we can say that the overall function will be negative. And similarly for this, if we will substitute a value less than this 1 by 3, then this will be negative and this also will be negative, so overall that will be positive, so this will be plus. So our interval will be from here to here, that is this y belongs to, we can say that y belongs to close interval 1 by 3 to close interval 3. So our range for this function is y belongs to close interval 1 by 3, so close interval 3. So from here, if the function can be surjective, if the function is surjective, then its domain, or we can say codomain, must be equal to range for surjectivity. So codomain is not equal to range of the function, because codomain is y belongs to r, and range of the function is this. So from here we can say that fx y is not surjective. Now we will check the injectivity of this function. So for injectivity, we can say that for injective, the function must be monotonic. What is the meaning of monotonic? That function must be either increasing or decreasing, not both. This must be either increasing or either decreasing. So monotonic. So from here, for this function, if we will analyze this function, then if the x is less than 0, if x is less than 0, then what will happen? This value will be negative and these two terms will be positive. So we can say that if this will be x square plus here will be plus 1 and here will be x, and this will be x square, here will be plus 1 and here will be minus x. So for x less than 0, if we will increase the value of this x, then this numerator will decrease and this denominator, this numerator will increase, because in the negative sign that will become positive. So numerator will increase and denominator will decrease. So function will increase for this x less than 0. And if x is positive, if x is greater than 0, so this function, the numerator of this function, that will decrease, because if there is a x is positive, then this will be negative quantity. So x square plus 1 minus a negative quantity, so that will decrease it. And here this, if this numerator is positive, this denominator is positive, then this x square plus 1, and this is a positive quantity which is increasing, so this denominator basically will increase. So function, or we can say x square plus 1 minus x upon x square plus 1 plus x, this will decrease for x greater than 0. So from here we can say that our function is not monotonic, because it is increasing in a something interval and decreasing also in something interval in its domain. So from here we can say that function is increasing as well as decreasing. So function fx is not injective also, not injective. So from here, since this function is neither injective nor surjective, so answer to this question will be option D, that is neither injective nor surjective. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.